worked with a good friend in India, Shibashis Das. We prototyped some processing systems using Scala, but instead of using typical Linux environments on PCs or something of that sort, we did the work on the IBM mainframe, which is Linux enabled. We found through doing that process that we were able to do a great deal of things with Scala, Java, Unix, using the development tools and libraries. In this video, I'm going to show you the results of that POC, the infrastructure components that we did through the course of that 3-month POC. You may find it interesting on how Z can to handle these kinds of workloads and do modern kind of language processing.
I'm going to walk you through here a few things that show you what we have been able to do. One thing that early on in the process, first few weeks, we were able to establish Github and Maven integration with Scala on ZOS. So this was just this morning as Shibashis made some program changes. This was a screenshot from the build process where we pulled across an updated version of our code and ran Maven to do the build processes. To my knowledge, we're the first ones to have successfully done Scala builds on ZOS. Okay.
So is this directly, so any changes to the Scala code in GitHub is directly getting integrated with ZOS, like in a DevOps, what we talk in DevOps? Is that what you're saying?
Yep. Let's go just run, show you a little bit more about the job. And I think maybe, Joydeep, to your question on the integration, let's just go, we're going to go do a poll, a Git poll from GitHub. We're up to date, so we'd have to have, we do Git branch. You can see that we're using the specific, instead of the master, we're using the code for JSOS. Our JSOS code has some specific Java commands in them. JSOS is a Java library for ZOS. For example, instead of using Java IO, it uses on Z, it uses C modules to actually do IO, which are much faster than Java IO, but they're wrapped in Java wrappers so that you can call those C routines from Java. So because we've coded for JSOS, our integration with JSOS, we're able to show that we can get a much faster performance than you could get under Java IO, but we're using Scala to call the Java IO, the JSOS library. And the JSOS library also gives us other benefits in that we can actually execute our processes under standard JCL processes. So those control reports you're seeing, all of the typical things that you can see in terms of performance and timings and those kinds of things are available to us in the standard ZOS outputs because we're able to execute our jar files under JCL. It also allows us to be able to access ZOS datasets. So the JSOS library has the ability to read, instead of just being able to read Unix datasets in Unix system services on ZOS, we can actually access the actual datasets under ZOS and process them with our Scala code. So for example, the transaction file that we'll be reading in this process is this ZOS dataset right here, and we're able to access that in our JSOS library and use that data within Scala. So if I run this, and this is running against our, actually, before we do that, let's do the Git, let's do Maven Build. So here we're using Maven Build against the Git repository. This environment is Unix system services on ZOS. So this is the Unix side of ZOS, or the Unix submodule under ZOS that you can access. So we've done our build there. So there's the newly built jar file. So when we go and run this under our JCL, then, oh, we just got an error of some sort, which shouldn't happen in your demos ever, but it did. That's our error. So, I forgot. I do have a limitation in that the jar file name, I haven't quite figured this out, but the jar file name built by Maven is too large of a name for me to fit easily in the JCL, so I have to make a copy of it to a shorter name. I think that's something we could get around fairly easily, but it does give you a little bit of a sense that the integration is not always clean. So I have to rename it to a smaller, just because of JCL length of parameters and wrapping JCL parameters is a little more difficult to manage sometimes. So that's, let's go see this running. So here we're watching the job run. We're running on SP12, which has 4 processors but no zips. So as this is running, we'll see here that we're using general processors. We'll see the CPU percentage. We're getting about 30%, a little less than 30% of the CPU as this runs. We can use the standard Java trace mechanisms to see what things look like that way. And we've even recently, in the last week, have started to use another tool called Health Center. I think I showed you that. Let me show you. This is what the Health Center looks like. You can see here are the different parts of Health Center. So there's a data file that we downloaded, and you can drill into these different processes and go find out where the time is being taken, percentage of time. And so there was a small change that this morning, or late last week, we just tested it out for the first time today. We pulled across a small change from he made in tuning the code, and we ran this under the old code 3 times this morning. We were seeing these kinds of timings running on run 1, run 2, and run 3. Run 3 we ran on SP13, which has 2 general processors and 2 zip processors. So you can see those run times. After the performance change, we ran it 3 more times, and you can see we're getting slight improvements on the performance. 2 times we ran on the zip processor. 1 time we ran on SP12. Okay. And that's completed. There's the completion time. If we go look at the output, so here is the output files where we can see the record counts for what we read and what we processed in our total set of views on Z. I could show you just real briefly. One other thing we could show you is the command for running the health check. We've been running that under ZOS, or pardon me, under Unix. So instead of running it in JCL, we can just execute the jar file here, and this executes the health center monitoring tool. And so now we're running the same thing we ran just a moment ago, but under Unix System Services. This will produce a file that we downloaded, an HCD file. And this is what you open within the Eclipse tool to be able to see what the performance statistics look like. You know, from our perspective, I think there's a number of first-of-a-kind things that we've done through this 3 months. We did Git on Z and the Maven builds on Z using Scala code. We weren't the first ones to use Git on and Maven on Z, but we were the first ones that I know of to use Scala on Z with those tools. We've integrated with the JSOS library with the Scala capabilities. So we're now able to use Scala in JCL. This would be helpful for our existing clients that have probably more than 1 million lines of JCL. Through using these techniques, we would be able to likely preserve some portion of that job stream and job scheduling, which is a very expensive thing to convert and build in other ways. So there's a great deal of benefit that could accrue to our customers for being able to do that. We've been able to use the SAF or common key buffer algorithms for doing a single pass of reading and updating master files and producing many outputs in that same pass. We've also been able to use the zips, which are the specialty processors that can help improve computing performance for certain types of processors, and Java is one of those. It's allowed, and we've also been able to use the Health Center to test out and get performance characteristics.